All right, get started in about a minute. In about a minute. All right, here we go. Share this with you. Any questions on last night's homework? Last night's homework. Remember number 10, it said broken line graph. It just means a line graph. Carson, you said no questions?
Yeah, no questions.
Okay, cool. That's not you. This is you. So this is what you are going to look like. We're going to do 12-2 today. Pretty quick class. We're going to take a 3-day weekend, come back and continue on with chapter 12. When we come back in person, not the Tuesday, or next week is still quarantine, but the following Monday, we're going to come back and do 12.6. And then a final word was on that Tuesday, Wednesday is when you're going to take your CMAS test. So you're going to take your CMAS test on that Tuesday, Wednesday. That's the language arts portion only. One of the days you're going to do 2 tests, and one of the days you're going to do 1 test. I don't know which one it is. And then we'll finish up with chapter 12. We'll take the test that next week. We'll do a little bit of prep for pre-algebra, and that'll take us to the end of the year. We'll do on a Wednesday, Thursday, Friday, we'll do a review for semester final. And then that final week of school, you will do nothing but take finals. All right, here, oh my word, there's only 2 problems. That must mean that they are complicated. It's not that they're complicated, but they will simply take time. You also need to have a protractor in order to do this homework. You're going to need your protractor to do this homework. All right, for some of you, I would highly recommend that you play this video while you're doing the 2 problems. It's just a procedure. I'll go over it one time, nice and solid. I'll do it slowly so you get the idea of what's going on. But when you try to do your homework, I would play the video so that you understand what to do. 2 problems. They must be crazy complicated. They're not that bad. All right, today is a class on pictographs and circle graphs, 2 different types of graphs. They are very different from each other, by the way, pictographs and circle graphs. We'll do each one individually, and then, like I said, there's only 2 problems tonight for homework. So 2 types of graphs today. The first one is called a pictograph. So think about this. Yesterday, last night for homework, you did bar graph, right? You did bar graph. Let's see, what's this bar graph on? Books published in the United States. It looks like the decades of the 50s, 60s, 70s, and 80s. So it looks like over, 10,000 books were, this doesn't mean how many books. This means, let's see, that means that there are 10,000 different, it's a little bit above 10,000, 10,000 different books that were published. And notice the number of books that are published is increasing as the decades go on. Here's another type of bar graph. It certainly looks like a bar graph, but it's not. This one is called a pictograph. So a pictograph and a bar graph look amazingly similar. It turns out that a pictograph tells you more information. Let's take a look at this bar graph for 1950. So for 1950, look, we can tell that it's above 10,000, but below 15,000 books. But I can't get a really solid, good estimate on this. I'm kind of guessing. Pictographs gives you a real good estimate. Look at, and by the way, these are the same graphs. Look at 1950. I've got 2 big books and a little book, right? And if we look at our little index right up here, it tells us each big book means 5,000 titles, and each little book means 1,000 titles. So if I look at 1950, I've got two big books, 5,000 plus 5,000 is 10,000, plus one little book. I mean, it's telling me exactly 11,000 books were published. For 1960, I've got three big books, 5, 10, 15,000 books were published. Notice we could get that same information. That's only because on our bar graph here, the bar goes right up to the line. Pictographs actually are a little bit easier to read than bar graphs, right? For bar graphs, you got to do a much more, looking to the left of the scales. But on pictographs, well, we do have to look at the index, and we do have to do some addition, but they're a whole lot easier. Look at 1970. We can count this. 5, 10, 15, 20, 25, 30, 35. So, and that's in thousands. So let's see, 5,000, 10,000, 15,000, 20,000, 25,000, 30,000, 35,000 plus one, 36,000, 36,000. Notice here's my scale right here for the bar graph. It's done the same way. So pictographs, you'll see these a lot in readings, right, that aren't primarily math focused. So they like to use pictographs. Also, have you noticed that the picture that they give you relates to what the data is about? Well, the data is about books, so they use a picture of a book to represent the data. If this was about lions, maybe they would use a lion head to represent lions. If this was about cars, they might use cars to represent something. But notice your key here in reading a pictograph is to find the index and make sure you understand. They don't get too much, like there won't be 20 things up here, but usually there's 2 or 3 things that indicate the size of the picture and what it represents numerically. So in this case, a big book represents 5,000, a little book represents 1,000 titles. All right, I can't make it that difficult because this part, the pictograph, isn't that difficult. So we better write some of this stuff down now. All right, definition, pictograph. It's a bar graph. It literally is a bar graph where each bar is represented by symbols, and those symbols represent a value. So it's still a bar graph, but the difference is instead of having a y-axis, the actual shape size of the picture that represents the data has a value. The big book was 5,000. The little book was 1,000. I see these all the time in infographics. They like to use pictographs. All right, pictographs, a bar graph where the bar is represented by symbols that represent the value of the bar, the value of the bar. Bar graph where the bar is represented by symbols that represent the value of the bar. That's a lot of represents words there. One more time, looking at the picture, that's a pictograph. It's a bar graph. Each one of those individual pictures represents a number, 5,000 for the big one, 1,000 for the little. You can do the math really quickly with this. All right, unless you tell me, I'm moving on. Moving on. All right, well, here's a pictograph. It looks like a picture of cars. And I've got one big car which says 1,000,000. Now, here's where pictographs can get a little bit messy. Notice there's only one car here, and it says one car represents 1,000,000. But if you look at and this is a horizontal bar graph, by the way, or pictograph. If you notice, sometimes I got a half a car, sometimes I got a third of a car, sometimes it looks like I got a quarter of a car, but they're not in the index right here. So you have to use a little bit of common sense. If it's a half a car and one car is 1,000,000, then a half a car would be 500,000 cars. If it's a third, I should be circling some things. So here's a half a car right here. That's got to be, well, if one car is 1,000,000, then half a car would be 500,000. Here's a third of a car, approximately. Well, a third of 1,000,000 would be 333,000. And I can continue some threes here, but I'll stop. So that would be 333,000. And then I've got a quarter of a car right here. And a quarter of a car would be what, 250,000 cars? So the second, I mean, this isn't another type of a pictograph, but the second time when I don't know, for me, the person's getting lazy that's making the index. I'm not going to attempt to draw a third and a quarter of a car, but they probably should put that in there, right? There's no harm, no foul of doing it. They did it with the books. Why can't they do it with the cars?
What was the homework?
It's just question 1 and 2 in the section.
Huh?
It's just question 1 and 2. All right, let's see if we can answer some questions right here. So question number 1 says, how many cars were sold in 1950? So I guess we got to find 1950. It's a horizontal, not bar graph, but a horizontal pictograph. So we find 1950, and then I guess we simply need to count. As we're counting, a whole car is 1,000,000. So we're counting by millions. 1,000,000, 2,000,000, 3,000,000, 4,000,000, 5,000,000, 6,000,000, 7,000,000, 8,000,000. Well, that's not hard at all. So it looks like there were 8,000,000 cars sold during the 1950s, right? Or 19. It's not per se. It doesn't say during the decade. It says specifically for 1950. This is a bit more challenging. It says how many cars were sold from 1950 to 1960. That kind of leads me to believe that it is a decade question, though. From 1950 to 1960, if I erase all the stuff I made. So I got to go from 50 to 60. I guess I could count once again. Well, let's count again. So we already have 8,000,000 in 1950. So 9,000,000, 10,000,000, 11,000,000, 12, 13, 14, 15. It looks like 16 million. So we got 16 million. So that's how you interpret or read a pictograph. Any questions on that? I can't make that too hard because it's not really that hard. The hardest thing is when they don't tell you on the index what a portion of a car represents, and then you got to do a little bit of fuzzy math there in order to get that answered. So the question is, how did I know that this was half a car, a third of a car, and a quarter car? Well, I'm just using a little bit of common sense. A full car is pretty obvious. A half a car would be, well, you can kind of see that in 1940, that's got to be a half. And 1930, that one's a little bit less than a half. So maybe a third. And then lastly, just the trunk, maybe about a quarter. All right, any questions on pictographs? That's it for pictographs. All right, the more challenging one that we're going to do, and it is a little bit challenging, is something called a circle graph. Some people would call this a pie chart, pie graph. Yes, that's what it's called as well too. More formally, they're called circle graphs. So it's a graph in the shape of a circle. So it's a graph that shows categories, and each category gets a part of a circle. So notice it's entitled World's Water. If we think about the oceans, you got the Atlantic, the Pacific, the Indian, and the Arctic Ocean. Other, right? Well, there's other world's water, right? We have freshwater lakes, so that would be the freshwater portion of it. If you didn't already notice, the majority of the water on Earth is salt water. All right, circle graphs. You've seen these before. Hey, look, we got a pie chart. You might not have noticed the detail in pie charts. That's what today's class is about. Circle graph that shows the value of categories using parts of a circle. Turns out that circle graphs, you can see 3 different kinds of circle graphs, and they all visually look the same. It's just how they represent the numbers. There's 3 different ways of represent the numbers. So the numbers that are in a circle graph can be given as percents. Well, that's this one. Notice that the percent would represent the portion of the circle. So the Atlantic Ocean is roughly 25% of the water on the Earth, and 25% would be a quarter of the circle. Now, I am doing a little bit of rounding there. The Pacific Ocean is less than half, 46%, but it's close to half. So that's why the little pie part of the ocean, Pacific Ocean, is almost half. And from there, you can see the rest. So this is one way where the values are given as a percent, but there's 2 other ways. Some pie charts, instead of having percentages, there's just straight up numbers. Here's an example. So it says a class vote, who wants to go to the beach, the zoo, or the mountain, right? So there are class votes. Notice there's no percentages there, but there are numbers. And those numbers would represent out of the entire class how many voted for it. This one's a little bit harder to interpret because it looks like it's pretty equal between go to the beach and go to the zoo, although I think I would be voting go to the beach rather than the zoo. But according to these kids, they, almost a bit more people wanted to go to the beach than the zoo. And it's a little bit harder to tell on a pie chart when the numbers or the percents are close together. Notice if I erase those numbers and I just show a portion of it, it would be hard to visually identify which is bigger, the people that wanted to go to the zoo or the people that wanted to go to the beach. Now, it's pretty clear that the green portion there is the smallest, but between the blue and the, I don't know, whatever color that is, brown or orange, that one's a little bit harder to visually identify. So one of the downfalls with a pie chart or a circle graph is that when the numbers are very close together, you better have numbers or percents there. Otherwise, you won't be able to tell just visually if the numbers are very close. Well, as I just alluded to, the last type of circle graph is one where there's no numbers. In other words, the numbers are not given. However, the shape of the pie or the pieces of the pie indicates which one is largest. So we got a school orchestra and there's no numbers there, but the area of each one of those pie parts, right, would indicate the size or the number of violins in the choir. So I don't know how many violins are in this choir, but I do know they make up the majority of the orchestra. And the smallest section there, well, that's kind of hard to see. It looks like it's either drums, trombones, clarinets, or flutes, right? One of those is the smallest, but since there's no numbers and the pie parts look to be about the same, I can't really tell. So there's some downfalls with circle graphs. This one's a pretty complicated one right here. The downfall is that if you don't list numbers, then the reader of your chart will have a hard time telling percentage-wise or numbers-wise which one is the greatest, which one is the least. We do like graphs that have pie graphs. We use this all the time, but we typically only use them when we indicate very clearly, either with numbers or percentages, the area of each one of those parts. All right, so three kinds. One has percents, one has just numbers, and one has nothing, right? But you can still at least ascertain or you can still indicate, as long as the pieces of the pie aren't that close together. I don't mean like physically close. I mean the size of them aren't very close. It's pretty easy to tell, oh, look, well, there's more violins in an orchestra than there are cellos. All right, so one of the reasons why there was only 2 questions is because, yep, you got to make one of these tonight for homework. All right, so this is the procedure that's going to require a compass, or a protractor, sorry. If you have a compass, the thing that draws the circles, that's good as well too, because we got to draw a circle. You can, use a coin, a bottle cap, something like that to make your circle as well too. So the good news is that the circle graphs are easy to read. The bad news is they're a bit challenging to make, right? So like I said, I'm only going to do one of these in class on the video. And for those of you that need help when you're doing your homework, I would play this video. I won't have the video posted until probably after 12. Probably by 12:30, I'll guarantee you I'll have it posted. But if you want to play the video while you're trying to make your circle graph, that would be a good thing to do. All right, so we're only going to make one. I realize that this is hard to do on an e-learning because I can't physically see what you're doing. If you want to just watch me do this, that's fine. But like I said, I would play this video as you make the graph itself. All right, so to make a circle graph, there's just a few steps. Here are the steps, and I'll pause and make sure that we can copy all this down. Step number 1 is you got to calculate the total. You're going to have numbers. They're not going to just say make a circle graph. They're going to give you some data. The data will have numbers. You take all the numbers and you add them up because you're trying to find the whole, right? Here's the more challenging part. You can use a calculator. It's fine. You're going to calculate the percentage of each pie part. So how do you do that? Well, you're going to be given a category. You're going to take that category, and this will make sense when we do one, don't panic. You're going to take that category with the part, let's say you have 10 of them. You're going to divide that by the total that you calculated in step one. And then it says you're going to multiply by 360. And the reason is there's 360 degrees in a circle. What you're really doing is you're finding the percentage or the percentage part of 360. In other words, what is the angle measurement for that individual category out of 360? If that made no sense to you, that's fine. Trust me, it will by the end here. You're going to do this for each pie part. If there's 4 pie parts, you got to do this calculation 4 times. You'll get a different number each time. Lastly, you're going to take those parts that you just calculated, and they will be in percents, in degrees, and you're going to make the circle graph. Okay, you do need a protractor to do this. So there's really only 3 steps. It's once you get the hang of it, it's actually pretty simple. But the first time you do it, and especially if you're just listening to, my words, it might not make much sense. So we got to do one. We got to do one. All right. So if you were copying that down, and if you were quick enough, you have all those steps. Remember, I'm going to post the video so you can review this again to copy down the steps. There's really only one thing you got to calculate. It's just part over total times 360. But you will have to do that for each category. All right, don't panic. I'll show you how to do one. Quick note, let's say that you had 3 parts, right? And you calculated those using that formula, and you got 75 degrees, 110 degrees, and 175 degrees. What would you do? So what would you do? Step number 1 is, well, you got to find a protractor because we got to measure those angles. Step number 2 is you got to draw a circle. Like I said, you can use a cover, a circular cover. You can, if you don't have a compass. Don't use a bottle, a water bottle cap because it's just too small. But if you have the bottom of your drinking bottle, right, that's probably pretty big. You need a pretty big circle to make your life easy. So once you draw a circle, step number 2 is then you simply draw a radius, 1 radius. And it actually doesn't matter where the radius is drawn. You see how I drew mine? All my circle graphs always look like this, right? You can actually draw that radius straight up and down if you want. Don't draw a diameter, draw a radius. But you need 1 radius, 1 radius. All right, here's what you do. What you do is now you take your compass. I'm going to try to illustrate here. You take your compass, remember the hole on the compass. You put your hole on the center of your circle. You line up the 0 line, here's the 0 line right here, with this part right here. And then what do we got to read? We got to read 75 degrees. So if I were lined up right now, 75 degrees would be right here. This would be your 75 degrees. If we count up from 0, notice there's 2 scales here. We don't want to use the outside scale because that's counting down from 180. We want to use the inside scale, 0, 10, 20, 30, 40, 50, 60, 75. So this red line that I just drew right there, this red line right here is what you would be drawing on your circle. So I draw that line, and now I have this part right here. There's going to be a category. Let's say this is, I don't know, for instance, let's say that's cats, right? So if this was cats, I don't know, maybe it was a poll they were taking. What's your favorite favorite pet? Cats, dogs, or let's see, what's another pet? Horses. All right. So we just figured out 75 degrees is right here. So this would be represent cats. Cats. Cool. Now comes the tricky part. Notice the line that I just drew, I'll draw it in a different color. I'll draw it in green. This line right here now becomes the new radii that we will measure from. So that green line right there, erase what I just did over here on my compass. That new green line will be our new radius. So that new radius where we'll line up this hole with again, we're going to have to turn the compass so that our 0 line right here lines up with this right here. So I'm going to turn my compass sideways. The hole lines up with the center. The green part lines up with 0. And now I got to read 110 degrees. So remember, this is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Hey, here's 110. So the line I would draw would look like this. But remember, you're doing this on the circle. So if I draw that line on the circle, remember my compass is there, right? I would wind up right there. So he said this was what? Dogs. So we would label this dogs. Oops, sorry. So we label that dogs. Dogs. Cool. Now here comes the magic. Guess what's left? Well, there's only 3 categories, so that would mean your last category you never have to graph because it's what's left. So there are your horses. That's pretty neat. So the last category, whatever your list is, if you only have 2 categories, you only have to make 1 piece of the pie because what's left is your last category. That's how you make a circle graph. What I left off there was the how to do the calculation. So I wanted to do this first just to get you comfortable with the process. As I stated before, I would play this video again while you're making up both this particular part of it and the next part. The next part is an honest to God example. Okay, so let's make this one. So here's what I want to read. It says the 7th grade voted and decided where to have the end of the year picnic. The results were the mountain park, 62 votes, the beach, 96 votes, and the city zoo, 82. We're basically making that graph that we saw there before. Well, what do you do? All right, so the first thing we do before we make a circle, before we do anything, is we have to calculate those degrees that we just did on the previous one. So how this is done, that was step 2, or step 1 was to calculate the total. So I take how many numbers are here? There's 3 numbers, 62, 96, and 82. I'm calculating the total votes that were counted. So all I'm going to do is add those up. Okay, I'm going to add them up. 6 plus 2 is 8, plus 2 is 10, carry your 1, and let's see, 8 plus 9 is 17, plus 6 is 23, plus 1 is 2, 24, so I get 240. So in step number 1, I calculated the total, it was 240. Step number 2 is the one that you're going to have to do multiple times. For every single category we get, we have to do this calculation in step 2. This calculation, I'll put a circle around it. This calculation this calculation right here, we have to do, let's see, how many categories? I have 3 categories. So I'm going to do this 3 times. Hopefully tonight for homework, they don't give you one with 10 categories. They won't, right? 3 times. So the first time we're doing Mountain Park, there were 62 votes. So 62 is the part. The total is what we just calculated in step 1, just adding up all the votes. And I'm going to grab my calculator and do that math. I'm literally going to grab my calculator. You can use calculator and do this math. So that'd be what? 62 times 360 divided by 240. If I type that into my calculator, I get 93, and that's going to be the degrees for that individual piece part. And that is for the kids that want to go to the mountain. The kids that want to go to the mountain, 93 degrees out of 360 degrees. I said we have to do this for every category. So the next category is the beach, right? There were 96 votes for beach out of the total. That was what we did in step 1 out of 240. I grabbed my calculator again, 96 times 360 divided by 240. I get 144. That will be in degrees. So I get 144 degrees, the kids that want to go to the beach. Lastly, we do it for the zoo. There were 82 votes. The total was 240. Grab my calculator, 82 times 360 divided by 240, and I get 123. Hey, pro tip, even though we know this is 123, there's only 3 categories. When you make your circle graph, you'll only have to graph 2 of these. The third one, will automatically be what's ever left over. Let me explain that one more time. So now it's time to make our circle graph. So the first thing you need, well, I need a circle. I need a circle. So I'm going to draw a circle. I'm going to use something to get me a circle. There's my circle. The next step is to make one radius. So I'm going to make one radius. I'm a creature of habit, so I always make it look like that. Now I grab my protractor. When I grab my protractor, I'm going to look at my first category, 90, oops, I'm doing a line there, 93 degrees. I need to make, with my protractor, 93 degrees. So I grab my protractor. Remember, I'm going to put it on the center of the circle, and I'm going to measure 93 degrees. Just be careful, 93 degrees. Right, 93 degrees. I'm freehanding this one without a protractor. 93 degrees is about like that. I'm using a protractor though. I mean, I can't show you a protractor on this program. So 93 degrees would be less than 90 degrees, right? I'm sorry, greater than, boy, I messed that one up. Let me do that one again. 93 degrees would be more than 90 degrees. So it would be more than 90 degrees. So about like that. As soon as you get that, now you're doing that with your protractor. As soon as you get that, make sure you label. So let's see, my label, this is mountain. Mountain. I should have hit the text thing, but I didn't, and I'm out of space. And we know that how many mountain votes were there? 62. So we put mountain 62. Cool. We don't put 93, that's the degrees. We put the value right here of the votes. 62 votes. If you want to put 62 votes, you could. All right, I'm going to make this a different color now because I'm going to have a new radius that I'm going to use. I'm not going to use the one that I started with. I'm going to use this one right here. So I'm using that one right there. And now I have to measure, what do I have to measure? I have to measure 144 degrees. Just be careful, right? You count up from 0, right? Don't use the outer scale, use the inner scale. So 144 degrees, I want to do a line, not a freehand. 144 degrees, I use my protractor. 180, roughly about right there, 144 degrees. So 144 degrees, we label now. That is, who wants to go to the beach? I want to go to the beach. Actually, I want to go to the golf course, but that's okay. I'd trade that to go to the beach. And let's see, how many votes for the beach? 96 votes. And here comes the magic. What's left, the part that's not labeled? Well, there's only one category. Well, that's got to be the zoo. So you don't actually have to do 3 of these, right? In fact, you don't even have to calculate this, the last one, for degrees, unless you wanted to. We do need to put votes, and the votes were what, 82? And that, ladies and gentlemen, is how. Now, granted, I apologize. I wish I could show you doing this physically with a protractor. Remember the protractor, the center of it has to go at the center of the circle, and the 0 line has to line up with, at the start, the radius, and then on the second one, that blue line right there to measure that 3rd line. Tonight for homework, you have 2 of these to do. So it's not like, this one will take you some time. You can use a calculator to do the calculation. Give it a good shot. If you run into any problems, play this video again, pause it, rewind it. If you still need help on it, send me a chat or an email. I'll answer you. If I'm not teaching class, remember I got other classes to teach, but after 2 o'clock, oh, we got out today, 2 o'clock, but after 2 o'clock, then, you'll get a more immediate answer. All right. Any questions? Danny, how do you feel about this?
Okay.
Well, good. I'm proud of you, right? This one, like I said, the first time you do it, you do it a little bit slow. If you play the video while you're doing it, I guarantee you'll do better at this. Literally, that's, I said today was a short class, but literally, I got nothing else. if we note, if I go back a couple slides and look at the one that we made versus the actual one, let's see how ours looked. That one right there. And notice, now, why didn't it actually look? It did look like this. Ours is just rotated a little bit more because we did the mountain first. So the mountain wound up at the top, and it doesn't matter where it goes. But notice that was literally exactly just turned sideways. That was literally, and the reason why ours was different is because remember, I started with my radius looking like that. So on my first one for mountain, right, our first mountain one wound up in that position, okay? But if you rotate this around, then you'd get the same thing. All right, that does it. Remember, Monday is off. Tuesday will be the next class. We'll move on through this. We'll do some more graphs. And oops, that was too many. Danny, if you didn't copy down your homework, there it is. It literally is just 2 problems.
Okay.
All right, have a good weekend, and I will see you guys on Tuesday.